Okay, this is chapter 6.7, Subtraction with Renaming. What is renaming? Well, we do it with subtraction whenever we have a number that doesn't quite work. For instance, if we have 32 minus 17, we have to rename. We cross this 3 out, we make it a 2, we add a 1 on our 2 and make it a 12. Now we can subtract. Before, we back up, you can't take 7 ones away from 2. You can't subtract 7 from 2. If you start with 2 and you try to take 7 away, you run out really quick. You have to have more up here. Now 32 is bigger than 17. So we can subtract 17 from 32, but it's hard for us to subtract 7 ones from 2. So what we do is we take our 30 and we rewrite it as a 20. It's like 20. And then we change our 2 into 12. 20 plus 12. 20 plus 12 is the same as 32. And then 17 is like 10 plus 7. And then when we subtract, 12 take away 7 is 5. And 20 take away 10 is 10. And 10 plus 5 is 15. So this is really the big picture about what's happening when we rename with regular numbers. We rename the 3 as a 2, and we just draw a line through it and write a 2 next to it. Remember that this 3 is not really a 3, it's really a 30. So this stands for our 20, this 20. And then we add the 10 onto the 2, which stands for the 12. And we can do it all right here in a micro. Instead of writing everything out like we do over here, we do it in small spaces right here. But some of us don't know what we're doing. We don't know why we're doing it. We're not exactly sure. We just know that it works. It gets us a right answer. This kind of shows longhand what's really happening. And today we're going to do the same thing with fractions. Here it's 12 take away 7 is 5. 2 take away 1 is 1. And we get 15. And if I were to add 17 and 15, I would get 32, which is our original answer. This is sort of how it looks, but we're going to do it with fractions now. And it's not really any harder. We just have to rewrite things and be careful. So we're going to start with a number. We have 2 and 1/2, and I'm looking at page 269, minus 1 and 5/6. This all looks fine until I rewrite it in a vertical format. 2 and 1/2, take away 1 and 5/6. Still doesn't look too scary because I don't have a common denominator. So if we use what we learned in the last lesson and we rewrite common denominators, 2 and 6, the common denominator is 6. So I've got to change 2 and 1/2 into 2 and some number of sixths minus 1 and 5/6. Okay, so we have 5/6 can stay the same because we already have the denominator here. And we just have to come over and change this one. 2 times 3 is 6, so 1 times 3 is 3. And 3/6 is the same as 1/2, so we're good. We can start subtracting now. Uh-oh, I have a problem. I cannot take 5 away from 3. And this is what we were talking about. So we really need to think about this 2 and 5/6 and figure out what I can do. I'm noticing the book, they use twelfths instead of sixths, and I don't know why they did that, but they did, and maybe I'll understand a little bit later when I look a little more closely. But we're using sixths, and it's a little different than what they have. But what I need to understand is that I still can borrow from this 2. I just have to cut one of my pizzas apart. 2 and 3/6, now look up here, 2 and 3/6 is the same as 1 plus 1 plus 3/6. And now what I do is I take this 1 and I just chop it up into sixths. How many sixths is it? Well, it's the same as 1 plus 6/6 plus 3/6. That's really what I'm doing. And 1 plus 6/6 plus 3/6 is really equal to 1 and 9/6. 6 plus 3 is 9. And our denominator stays the same. So we're really going to rewrite this as 2, nope, not 2. We're going to write it as 1 and 9/6. take away 1 and 5/6. And now it's something we can actually subtract. 9 take away 5 is 4. 1 take away 1 is 0. So it's 0 and 4/6, which is just 4/6. We don't need to write as 0 and 4/6. There's one more step though, because I can simplify 4/6. I can divide by 2 halves, or by 1 really. I'm dividing by 1. But I can divide both 4 and 6 by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So my answer is 2/3. Okay? Now, I guess it would make sense for me to do it the way they did it real quick. They wanted to find a common denominator and then use the common denominator to write equivalent fractions. So we've got 2 and 1/2 equals 2 and 6/12. That's what they wrote. And they also wrote down they wrote down 1 and 5/6 minus 1 and 5/6, which is the same as 1 and 10/12. And this is the same problem we just did. They're just using 12ths instead of 6ths. And they changed both of them. And then they left kind of a blank, and we got to figure out what to do with it. And if we just show our work, 2 times 6 is 12, so 1 times 6 is 6, and that works. 6 times 2, it's supposed to be a 2, is 12, and 5 times 2 is 10. But I still have to change my 2 and 6/12 into something. So I can rewrite it as 1 plus 1 plus 6/12, and then rewrite this 1 as 12/12 plus 6/12. And then 6 plus 12 is 18. So this is really 2. Oh, I keep doing that. It's really not 2 anymore. It's 1. 1 and 18/12 when I add the 2 and the 6 to 12 and the 6 together. 1 and 18/12 minus 1 and 10/12 equals 18 take away 10 is 8/12, and 1 take away 1 is 0. And I have to simplify again, and I'm just going to do the same thing. What can I divide 8 by that I can also divide 12 by? Well, I could do it by 2, or I could do it by 4. And I always want to choose the biggest number. So we're going to divide by 4. 8 divided by 4 and 12 divided by 4 is 2/3. And that's the same thing I got with the last problem. This just looks a little more like how they did it in the book, and I think that it's important for you, if you're working with your book, to get the same kind of things that they have going. So it says rename mixed numbers as fractions greater than 1. So sometimes that's all you have to do. Find the difference in simplest form, estimate once in a while. They want you to estimate sometimes. Let's look at the one on page 270. They've got estimate 1 and 3/4 minus 7/8. And then if you estimate, you get, actually I guess we should write, instead of an equal sign, we should write an about sign. It's like an equal sign that's wiggly. 1 and 3/4 turns into 2, and 7/8 turns into 1. 2 take away 1 equals 1. We go ahead and do the problem. 1 and 3/4 minus 0 and 7/8. We don't have to write the 0, but we have to line those up like that. Well, we need eighths. So we're going to write 1 and some number of eighths minus 7/8. We already know that this one's already in eighths. 4 times 2 is 8, so 3 times 2 is 6. 1 and 6/8 minus 7/8. 6 take away 7 doesn't work, so we have to rename this. And you can do this in your head. This would be, let me just write a little 8. What we could do is we can cross this out, and remember that this is 8/8. This time it's if you add 8 and 6, you get 14. So it's 14/8. Sometimes we want to just add the 1 here, and that's 16/8, and that doesn't work. We have to remember that it's 8/8 plus 6/8. So this is really 14/8. Take away 7/8. So we kind of have to move one step over. I hope you see what we did. It's the same that we did on the other problems. And the 14 take away 7 is 7/8. So our answer is 7/8, and we kind of see that that's really close to 1. And so I guess that answer works. One more, just for fun. Let's just throw in something weird like 6 minus 3 and 1/2. Notice that there's no fraction with 6. This is like, what is that? So it's a good thing that we pointed this one out. This is 6 and 0/2 minus 3 and 1/2. Now you see, it's really just 6. But I can use any number of any size piece I want. We're using halves down here, so we might as well do 6 and 0/2, take away 3 and 1/2. But we still have to change it. Because 0/2 is too small. We can't take 1/2 away from it. So we're going to change 6 into a 5. And we take that extra one and change that into 2/2. See how 5 and 2/2 is exactly the same as 6 and 0/2? Hopefully you can see that. Minus 3 and 1/2. 2 take away 1 is 1/2, and then 5 take away 3 is 2. So 2 and 1/2 is our answer. If we had estimated, we would have done 6 minus 4, because 2 and 1, that one we could almost do without all this work. We could actually sort of do that one in our heads. 6 take away 4 is 2, but we know it's not quite 4. If we did 6 take away 3, it would be 3, and since it's 3.5, it would be right in the middle, and it ended up being 2.5. Some of us can do 6 take away 3.5 in our heads. This is the estimate, and this is our answer, so it makes sense. We can just keep working. All right, that's all I have for you. Just keep working like this, and you'll do fine.